2 years ago, we were developing a 2D mobile game called Chunky Cat. It was about a cat jumping around and earning some calories, as you can see. We were a small team, so every bad decision could kill the project. So one of the most critical decisions we had to make was about how to deal with the animations. We needed a scalable solution targeting mobile devices and being productive at the same time. So we decided to use Spreadsheet animations for the simple dynamic characters like pigeons and rats and enemies with simple animations. But we decided to go skeletal animations for the main characters, the cats, because we required a more flexible approach. So nowadays, Mandarina Games is a team of 2 based in Barcelona. Joaquin Vigili, the business guy, and me, the code guy, Sergi. We like to make games, but right now we're starting to make tools for Unity because it's also very fun to do. So I first would like to compare very briefly the difference between Spreadsheet and skeletal animations. I know that you probably know, but just for the ones not familiar with it. And to illustrate, we will use Chunky Cat archenemy. Spreadsheet animation requires drawing the animations frame by frame, usually by hand. So usually it requires big textures, and that makes your storage grow. So it's not good for mobile in some cases. So it is time-consuming to make changes because you need to fix. If you want to fix your sprites, a small detail, you need to go to all the sprites all together and apply this small fix to all the animations. Also, smoothness depends on how many frames you draw. So it's very hard and has a high cost to have smooth animations. And animations cannot blend, so you need to make these animations to make transitions between running and jumping. On the other hand, this technique offers great performance. It's very easy to draw these sprites, and you can draw thousands of them. So skeletal animations allow you to reuse common parts between animations, so you end up with smaller textures. If you change one of the images, you already changed all the animations, so it's good. It's more flexible. Also, it's smooth because all the animations are sampled using curves, so all the in-between frames of your keyframes are calculated. So you get smooth as your frame rate is. And you can make slow-mo, for instance. So you can also blend in between animations, like in 3D. You can blend running and jumping, and it looks good. You can deform your sprites using 3D world techniques like skinning and blend shapes. You can modify animations at runtime and create several cool effects, and this is called procedural animations. But at last, this technique is more CPU and GPU intensive compared with the other one. How can we produce skeletal animations in Unity? It's simple, just parent sprites to transforms and animate the transforms using the animation window. The thing is that what makes skeletal animation cool and impressive and time-saving is skinning deformation. And to enable skinning, we need precise control of the geometry, of the underlying geometry of the sprite. We need the concept of bones, and we need high-quality weights. So to do that, you can use external tools, and you can use Unity plugins. External tools are great, actually. They are battle-tested, they have a big community behind, they offer a great workflow, and they are multi-engine. On the other hand, they need Unity integration. These tools, they export files and textures that they need to be interpreted in the Unity editor, so you can use them in Unity. Unity plugins are, on the other hand, tailored to the editor. You can see the changes immediately in your game. In external tools, you need to go back and forth from time to time and export, then re-import in Unity, so that stops you to see the changes very dynamically. With plugins, your assets are already updated. Also, they enable the maximum performance in Unity because they use only native components and assets that Unity are optimized. So we decided to make Anima2D because it was our attempt to bring that great workflow that external tools provide inside Unity. Because the existing plugins that we found at that time, they differ a lot. The workflows were already very different. And external tools did one thing, and internal tools did another thing. So we tried to bring that great workflow inside Unity. So Anima2D offers nowadays a full control of the sprite geometry, automatic waves, ShapeAware, it's important. Also, you can edit them manually. I'll show you later. You get bones in the scene view. Also, you have a small 2D inverse cinematic system that helps you edit your animations, and full editor integration. That's very important. So it's demo time. Okay. So first of all, I have this texture here. It's a T-Rex divided in several parts. So we're going to start working on this one. What you need to do first is to slice them using the sprite editor, as usual. It's very easy to do, and I guess everybody knows how to do that. And then you need to create a sprite mesh. Sprite mesh is an asset that will hold your sprite and make modifications and, well, internal things. We need another asset. So just select Anima2D sprite mesh, and we'll generate them. And you can already actually drag them into your scene. So what to do now is we need to create bones. We can select 2D object bones. And here is our bone. Our bone can rotate. You can drag it. You can change the color if you want. And you can hide it using the alpha value. You can still select it and manipulate it, even if it's hidden. Also, you can set in a different layer, and it will work, the locking and hiding. So we will continue with our leg. We will get a matching hierarchy in our image, approximately. Okay, cool. Now we have to open the Sprite Mesh editor. Sprite Mesh editor will allow us to change the pivot point in this case, but also to change the geometry. You will be able to split edges and add all the vertices you want. You can add new edges, so to enforce triangulation. It's very important to control the triangulation because that will define how your sprite deforms. You can get inner vertices too. But I also implemented a small slice tool. You can select the region of your sprite and we'll slice it for you. We can select some more detail, tessellation, if you want holes or not. So I think it will work this way. You can apply changes, and you can see that the geometry is already there. And now it's time to set the bones. Usually you would rename this hierarchy using the appropriate names, but just for illustration purposes, I will save some time. You can just set the bones in the hierarchy. In this sprite mesh instance component, sorry. And you will get the list here, and the bones will appear in the editor. You can still manipulate them, and we will refresh the changes. So, and now we need to create some weights. Weights are the key part. So we can hit the bind, and now bones will convert to bind positions. I mean, these colored bones are bind positions and are baked to your mesh. So they will stay there forever. Don't try to move the bones because they won't change. Now you can see how the weights went. You can see the overlay color, and we can just apply changes. Let's see how it worked. When you hit apply, you already have your skinned mesh renderer set up automatically. So you can start to evaluate the results. So it looks quite okay. So for the ones that need more manual refinement of the weights and fine-tuning, you have a small weight editor, weight tool. You can select bind position, and you can increment or decrement the weights. If you hold the control or the command button, it will increment or decrement only the affected ones that already had influence and not modify the rest. You can smooth them and like mix them between the neighbors. Yeah, and that should do the work. You can also visualize some pies here. Okay, so now what's the problem? The problem is that meshes that overlap themselves, they show problems. So to fix that, you just have to come back here and just assign a priority, an order to your bind positions. For instance, we'll set number 1 here, number 2, I mean, negative values would be behind, number 3. And now when we hit apply, it behaves as we expected. Okay, so now we can just remove that. And if you do that to all your sprite meshes, then you are ready to build your character. I will use mine that I already have set. And you can just drag and drop, and your bones will get reconstructed. So a skinned sprite is both geometry, but still bones. You cannot go one without the other. Then we need also the body. We need the back of the mouth. It will get attached to it if it finds the same bones. So it's easier to reconstruct your character. And then the other leg. Of course, you need to set up the ordering layer that makes that look okay. And now you just need to reparent your legs to the hips. Yeah, and now we have our character reconstructed and ready to go. Okay. Also, I want to show you the importance of the ShapeAware Automatic weights. I already have this guy here with the geometry already set up. And this is quite a proper example because it has like two legs very close together. And what would happen if you have a weight calculation algorithm that doesn't take the shape into account? You would probably end up with one leg having influence in the other leg. And then would be totally wrong, and you would need to change it manually and spend some time. In this case, our algorithm, just you hit bind. And as you can see, it respects the shape. And if you hit apply, you're ready to go. You can just see that looks quite okay, just with a single click. Now I need to show you how to create some animations. To create some animations, we need to proceed with the animation window. We set up a new animation, and then we can just enable iCase. iCase you have two kinds, like CCD for a chain of bones, or you have the limb for limbs. It will take two bones into account, and it's a little bit faster to calculate, so it's more appropriate. Also, you have a pose manager. You can load positions. Also, the iCase will get into the right position. And that helps us to store positions and then load them to build the animation we want. For instance, we can just start recording, and we can set the base position. And it will store the bone keyframes for you. And we can end up with the other position. Then in between, you can just start playing with iCase. Right now, iCase, what we'll do is to store bone keyframes. So let's see, head, yeah. When you preview, as you can see in between, the tail is not following the IK, because right now what it does is just help you to store these keyframes directly on bones. I'm thinking about changing that in the future, but at the moment is what it does. So also we have controls. Controls are just objects that are always shown in your scene view, that will help you operate the most significant bones that you think that you use the most, so it will be easier to focus on them. We can drag it this way, and then just preview your animation. Well, doesn't look quite okay, but I guess you guys, if you are animators or artists, you will do better than me. So, let's continue. Here we have Unity Chan version in 2D. And what I'd like to show you is that it takes one draw call, one batch here. How we achieve that? We achieve that by combining meshes. at runtime. So you have at editor time a bunch of sprite meshes here. But at runtime, I made a small component that it's called Skinned Mesh Combiner. It's a version of one component I found in the community. But I adapted it to my plugin. So you set the list of sprite meshes instances from back to front, and it will combine them in a single mesh at runtime. Also, to enable that, it's very important that your sprite meshes, they use all the same texture. So you can use atlases. You can pack them together, but just make sure they use the same texture. Because sometimes they pack, the sprite packer, they make different pages. So different pages are different textures. So try to make just one texture. Otherwise, it will look incorrect. Also, in this special case, I added some procedural animation. You can add some spring bones in the hair and the ribbons, and it will just make this cool effect. What else? We have this guy here. This will be included in the next version. Some people ask me to also to swap skinned meshes. The thing is that Unity you can only animate sprites, not any other kind of asset. So you need to make a component that you set up a predefined list of sprite meshes that you would like to use, and then you can animate this value. You can animate the index, the frame, and it will work. Also take care of the curves. You need to set them constant, otherwise. But this will be included because also make sure that all your frames here, they use the same bone list. Otherwise, you need to specify the sprite mesh and the list of bones. But you can still do that, but not with this component. This is too simple. But it will work if they use all the same bones. Also, a thing that I'm experimenting with that maybe we'll include it soon, or is this. Let's see. Yeah. Just some onion skin that helps you in the animation process. You can set maybe more frames, you can change the color, but well, stick to red. And you can enable and disable it, and you also can change, and you will see the preview update. But this is still in the roadmap, but I don't know when it will come out. Still need to fix some things. Okay, that's it with the demonstration. So, well, thank you very much.